we doing?
Oh.
Yeah.
I forgot we had to do that.
Sorry about that. You have to get it in your rhythm, okay?
Yeah.
Alright, you gotta get in the rhythm of that. Although I did have someone else like, I forgot to post pictures. Okay, post me a comment. Like, I forgot. It's not gonna last for much longer, but I might give grace for a couple more submissions. Maybe like one. And I'll write you a okay, but alright, you guys are grading 2, 4, 10, 20. Independent, dependent, you should have some descriptors as to what's going on. Number 4, the difference quotient. That nasty formula. Number 10 is a no. I think it's no, yes, no, yes. Yep. Not a function, yes, a function, not a function, yes, a function. Why is number 20 a no? That was a little bit weird. Doesn't even look like an equation. Where's the y? That's the point. There is no y. What does x equal 1 look like, guys? What kind of line?
A vertical line.
A vertical line. Because this one's a function. He's great. Each x has one and only one y. There's no point on top of each other. But this one fails how badly?
Very bad.
Horrendously. There's infinitely many y's for each x. Incredibly sure. So x equals 1. Definitely not. It is a vertical line. A vertical line will fail the vertical line test. Yikes. Okay, number 36 and 56. 36, that piecewise function that we talked about on Friday. Did you plug in the pieces to the appropriate places based on the inputs and the inequalities? Good. 1 and 2 are both less than 3. Therefore, f of x, those x's needed to go into the first piece. 3, 4, and 5 are greater than or equal to 3, so they only legally fit into the second piece. And then they just put it all on the table. Sweet. Number 56. How'd you figure out domain? Denominators can't be. You guys see the statement? Domain problem. Denominators can't be 0. Hence, we had to factor. Did you find both of them? Domain is all real numbers except x cannot equal 0 and x cannot equal 2. Had to factor. And number, didn't you have a, oh, I only gave you difference quotients that were odds? Which means you were supposed to look at them in your groups. But number 68, I'm pretty sure he was kind of weird. So let's go ahead and go to our homework. Number 68, the final answer, if you guys want to check it out, was between 0 and 6. I wouldn't have been totally disappointed if you had put negative 6 to 6. I wouldn't have been totally disappointed if you put negative 6 to 6. But what questions do we have? Odds or even? Let's go. 68. 68. Okay, anything before 68? 66. Anything before 66? I didn't even have 66 on there, did I? 49? Okay, let's start at 31, going to 49, then we'll go into the 60s. So, Sid, 31? Okay, 31 was, a piecewise function. Oops, I need my little hand. There he is. Okay, I think you were just plugging in, right? Function notation, f of. Why did I say f of and make you guys say x? What are we supposed to think about when we look at the -1, the 0, or the 2? They are what kind of values? Independent. Good. Independent, aka x values. So we have to look at these restrictions, right? Because the first piece is only legal if x is less than 0. The second piece is only legal to be used if x is greater than or equal to 0. So therefore we have to test our x values. So what piece should -1 have been plugged into? Because -1 is less than 0. So 2 times what plus 1? Plug it in, plug it in. But where would 0 have been plugged into? The second one, because that is the truth statement where for the inequality where 0 fits or where 0 is able to legally be applied. And then f of 2 is definitely the second one, right? Greater than or equal to 0. So as long as you simplify correctly, I have -2 plus 1, 0 plus, and 4 plus. That's one. Then make a table or something. Is that cool? Yeah. Don't forget next time. Except nutrition, you're gonna be We're going to number 80, 49. Number 49 gives us domain. Do you guys notice that domain wasn't covered afresh or anew in section 1.4? When did we first cover domain, guys? No, but this year. Table of contents in your notes. Come on, let's go. Domain problems. I made you like highlight it, star it, or I told you you should. What section was it in? Who finds it? Probably not the linear section. That one has boring domains. It's all real numbers unless you have a vertical line there. 1.4? 1.3? Find it in your notes. Come on, there's a place that says domain problems. We talked about polynomials. Yeah. 1.4. Yeah. Oh, at the very beginning? Okay. I thought it was 1.2. My bad. Nicely done. Way to argue for what you know to be right. So in section 1.4, guys, this is huge. It's super important for the entire year. It was 1.4 at the beginning, though, wasn't it? Too far. Domain talked about x's, talked about how left, how right, and then we talked about domain problems, right? Did you highlight it? Okay. We're going to be referring back to this again and again and again. When we get to trigonometry or trig, we're going to actually expand on it and add a few more domain problems. So, in the section that Adrian was asking about, which was, here we go, 49 to 60, we were looking at number 49. So, easy is hard. Does it have a denominator? No. Does it have a square root? No. Does it have a logarithm? No. Does it have any trig? Just kidding, we haven't talked about it yet. But no trig either. That's another problem. That's going to come. So, if it has no problems, what does it mean the domain is? It was tricky because it was easy. Which is why, what did I say in the notes? And I kind of referred to it again today when I was asking you to look for it in your notes about polynomials. All polynomials have a domain of, Nikki's so offended right now, all real numbers. All polynomials, all real numbers. And what was true about number 49? He's a polynomial. How about number 50? He's a polynomial. So both of these were all real numbers. And then we're going to number 66, yeah? Okay, 66, oh, just kidding, I thought he was a difference quotient one. So guys, we're good on difference quotients? Oh my goodness, alright, well, there you go. I'm double checking something real fast. Oh, I did give you 66, my bad. Do I have a picture in your notes though? I feel like I have a picture waiting. Oh, look, I had 49 also. So no questions on 77, 81. We'll come back to it if you do. 66 and 68. There we go. Okay, 66. Should have made you feel like the NFL field problem. Did anybody feel a similarity to that problem? Some of you just didn't even try. Shame. Boop, boop. Because number 66, you have a geometric figure. Now it's three-dimensional, so it's not just a rectangle of the NFL. Is rectangular solid, I think technically. But they are asking for v to be written as a function of x. But hold on, go back to what you know. Volume. Volume of a rectangular solid. What's the volume formula? Don't do the x's. Don't do the x's. Do the geometry. Do the geometry.
Length times
Good.
times height.
Length times width times height. Go back to what you know. Then we'll figure it out. Now look at the box. So what can we replace length with?
X
We could do x.
squared
We could do x times
times y.
times y. Sure. X times y. If you think about the dimensions of the box. So. Oh, I'm sorry. Length times width times height. It happens. It happens every year. Length times width times height. X times y. So now we have an equation. But do they want the y? No, but we have to keep it legal. So we can't just take the y out and ignore his existence entirely. So how do we deal with that y? What else do we want? What else did we have in the NFL problem that we were able to substitute with? I think we had a clue with a number, didn't we? Do we have a clue with the number in this one? So what is 108? This is where some of you might have
It's
gotten
the perimeter of a cross section. Or no, it's the maximum combined length and girth.
Okay, yeah, then we got lost. We're like, okay, so perimeter of a cross section. The cross section.
An area where 2 points meet.
I like to think of a cross section as a slice. That's something I talk about in calculus. You guys probably haven't really heard cross sections before. Can you imagine this as a loaf of bread?
Yeah.
Okay, slice it. Well, okay, it should be a very boxy loaf of bread. Okay, if you were to slice it, what would the shape be?
Square.
Yeah, a square. What's the perimeter of a square?
Length
No, that's area.
Oh.
2 times 1 of the sides.
Okay, so 2 times x plus 2 times x. Oh, wait a minute, you could have just done. Perimeter of a square is side plus side plus side plus side, or 4 times the side. Okay, 4s is the perimeter. S squared is the area. Remember there's those formulas in the book? Involve the following mass theory, the perimeter of a square. Now, you might not have known that that was a slice and a slice is a square. But what else did it say?
Length
Girth.
and girth.
Oh, length. What's length?
Y.
There we go. So what can I do with that to solve my problem of needing volume in terms of x and having a y in that formula?
Subtract 4x to get the y.
What if we get y by itself and then what's that snazzy term of
Plug it back in.
The snazzy term for plugging in?
Substitute.
Plug and chug works. What's going on with letter B? Because basically we're done, right? I can just rewrite this as b of x equals x squared times 108 minus 4x. What else? What's letter B saying? Graph it. Why am I graphing it? Why did we graph the NFL one? What are we trying to find? Oh, B just says graph it. C says, what's that really cool feature in your calculator? Second trace button that it can do for you as long as you get the picture out. Zoom in, zoom out, zoom fit, zoom play. Just kidding, that's where you have to manually adjust. Maybe zoom square. You're trying to find the maximum, right? But you need to find the max. I think this is one where it ended up doing something like this if you zoomed out far enough. There's a max. There's a max somewhere. You just gotta find it. And here's the struggle. I think you need to end up going to a window where the x's were something like 50 and the y's were something like 10,000, 20,000. I think if you went to 15,000, you'd see it. Do you guys know that there are those preset zooms? Zoom in, zoom out, zoom fit, zoom standard, zoom trig, zoom stat. There's all sorts of zooms. But there's also something that you could do yourself if you hit the window button. More and more we're learning how much we need to learn about our calculator. Good thing that calculator section's coming next week. But window, you can make your x min and your x max manually what you want it to be. Now, I really wish it was a pinch zoom. It'd be so much easier if you could just pinch zoom in. But you can't. You have to somehow tell the calculator what you want. So you could have made the x min something like, I think, negative 50 to 50 would have been great. And your y min, y max. You guys realize your y was your volume and your x was your dimensions. So if nothing else, you knew x definitely couldn't go over 108 and actually be smaller than 108. Because x, 4x plus y has to all combine to be 108. That's maybe why 50 makes a little bit of sense. Or 100 or 150 would have been more than enough. But if volume is multiplying length times width times height, and if the length, width, and height could be anything between 0 and 108, well, if you did like 108 times 108 times 108, worst case scenario, which is impossible because that's using up all of that 108 like 3 times, you would have had more than enough as far as how high to make your y. I always like to have a little bit of negative. I like seeing a little tail end, but you don't need negative volume. It doesn't make sense. You need the positive one. And if 108 times 108 times 108, 100 times 100 times 100, will be one with what, 6 zeros? It should be 1, 2, 3, 4, 5, 6. That'd be a million. That'd be way too big, but at least you would see it. But we didn't have to go quite that crazy high. 15,000 is big enough. But some of you guys who were just zoom out, zoom out, zoom out, zoom out, zoom out, or you saw a line and you're like, there is no max. This problem makes no sense. The window was weird. X didn't have to go very far, and Y needed to go stinking high. Has anybody gotten the graph on their calculator? I see a few of you playing with it. Any luck yet?
Yeah, I got it.
It might look different. Is it like an M? Ooh, hold on, your window down.
I put the zoom fit, so I don't know.
Okay. It does end up coming from forever and going to forever, totally right. But do you guys see Ethan's calculator? Do you see a max on that? But he did it in a way that he zoomed out, zoomed out, zoomed out, I think.
I just put zoom fit.
Oh, zoom fit.
Yeah.
Here's the sad thing. Zoom fit has it to where this little portion that he needs to see is like totally squished. To where it doesn't even look like it's there. Now he put it in right, x squared times 108 minus 4x, but what he needs is to make that window. Woo! Where are you going up to? 1.2 million. That's assuming they're all 108. We don't need near that much. So I'm going to do my negative 20 on his window. I'm manually entering it. And I'm going to like 20,000. Let's see if that's any better. You guys see a max now? I didn't change the equation. All I did is change the window. The sad thing is, if the window is wrong, sometimes what's meant to be seen is like squished because of the perspective. So the weird thing is, when you input it completely right, but depending on the window, it could be completely confusing because you don't know exactly what's going on. So is all this telling us that we need to learn our calculator better? All right, it's coming. Hang in there. Hang in there. Number 68, though, this was actually easier than number 66. You had a semicircle. With a radius of 6, I can tell because I'm really familiar with graphs of equations. You will be hopefully by the end of this course too. They said something about throwing a rectangle in, but I think they even gave you a picture in homework, didn't they?
Yeah.
Now the weird thing is they labeled this guy with an XY when you guys could have counted tick marks over and up. Some of you might have like actually put those numbers in when actually they meant for you to keep it general. Because the rectangle could have been drawn here at a different XY, could have been drawn here. They didn't show you all the different rectangles that could be inscribed. They just showed you one and said, keep it general. Keep it general. So when they said write the area of the rectangle as a function of x, guys, go back to what you know. What's the area of any rectangle? Ignore the picture, ignore x is 1. Base times height or length times width. Yeah? Okay. Base times height or length times width. Now, how do you go to a point xy? What does x actually measure? Can anybody explain to me what x is? How far left or right? Positive would be right, negative would be left. From the origin would be the best way of thinking about it. Hold on. Did you guys just take notes in section 1.5 that kind of showed that x goes from the origin out to a point and y goes up? So let's use that. So x goes, let's say we're using this rectangle. X starts at the origin and says how far over. And y says how far up. Something so basic and yet so hard when you have to do this problem. What would the base be of this rectangle if I'm trying to represent its area with a formula?
2x.
I need 2x's to be the base. See it? X went from the origin out, and this rectangle was straddling the y-axis. I have half on this side and half on that side, so therefore my base is 2x, and what's my height? Something so basic and yet so confusing. Now hold on. They want area as a function of x and x alone. Well, I need to substitute. Good thing they gave me a clue. You guys see it? Plug it in, plug it in. What are the problems you had at lunch? The NFL playing field, the boxing mail, whatever, restrictions, I don't know, and this one. But did you guys see similarities? In all of them, you had to go back to geometry and remember old school formulas. Whether it was area and perimeter of a rectangle for the NFL one, whether it was volume of a box for the one we just did, whether it was area of a rectangle for this one also. But it wasn't enough to remember the geometry. You had to take the geometry and apply it to the problem and somehow get X's and Y's in based on whatever you were given. And that was weird in that box mail one with the girth. And okay, that was weird. I agree. But you were trying to take the geometry, make it specific in terms of X's and Y's, and then go looking for a clue that sometimes is given to you outright or sometimes is implied, like the whole 108 thing. Now, I'm going to ask one last time. Be courageous, be bold, if this is you, and if it's not, then we truly will move on. Did anybody want to see anything to do with the difference quotient again, specifically numbers 77 or 81? Which one? Yeah, I'd love to. Thanks, kid. If there's anyone in here who was like, yeah, I wanted to see it, but I didn't want to say anything, can you just say thank you right now? Okay. There's no shame in having a question, but in not saying it, you're just pretending like everything's great when multiple people were like, no, I was stuck. Okay? 81. Did you guys notice the difference quotient shows up in different forms? Because technically in our notes, wasn't it f of x plus h minus f of x all over h?
Yeah.
And we could have made it g of x plus h minus g of x all over h, but even then, it doesn't look like this. So there are different forms to the difference quotient. John, can you be our hero and pop the door open? You guys can say thank you to John.
Thanks, John.
All right, so if it doesn't look exactly like the one we did in our book, do you think I'm trying to challenge you guys on taking a complicated formula piece by piece to plug in? What was allowed to stay the same was the division bar, the minus, and the x minus 3. There was no plugging in necessary. There was no application or need to bring in the g of x. So he stayed, but what do I need to put here?
1 over x.
1 over x squared, who the g of x or what the g of x is. And then what do I need to put here?
1 over 9.
1 over 9, which comes from 1 over 3 squared, which comes from plugging 3 into g. So even if it looks differently, there's still the idea of this big formula that needs plugging in when there's a specific function attached. Now, was that what the back of the book had? Awkward. Those of you that did check. The answer is no. Because I believe the directions were to find the difference quotient and then simplify. And that's not simplified because I see a fraction and a fraction, otherwise known as a complex fraction. You guys ready for your first introduction to my shortcut to simplifying complex fractions?
Yes.
That you'll see over and over again this year. If I were you, I'd get a color pen out because this is kind of a big deal. Like calculus took like a whole day to review this when they were reviewing their summer. 1 over x squared minus 1 over 9. Huh? Like summer reading, but easier. All right, come back. We're totally still in August. Breathe. Okay. Ready? I learned this one in Uganda when I went on the mission trip with Heritage. The very first year it was Heritage. And I was in a math classroom in Uganda because their classes are like year-round instead of just the normal. And they have longer breaks in between the year-round. Yeah. Take a breath. It's not you guys. But I thought it was a really cool trick, and I totally brought it back, and I've been using it ever since. Do you see how the 9 and the x squared are giving me problems? If I was to do a common denominator, wouldn't I try to get it to be 9x squared? So my trick is multiply top and bottom, and multiplying by 1 creatively, by the common denominator of all my little baby fractions that I need to have simplified out. Now, parentheses are key. Parentheses are crucial. Isn't the name of the game distribute, guys? Because fractions multiply across. So what happens when you distribute 9x squared over x squared? It becomes, in just a second, which some of you, when you get good at it, will go straight to 9. What happens when you distribute 9x squared to one ninth? And what's on the bottom? I like putting the monomial in front of the binomials just because of order. Dun, 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 dun. Wait. Ooh, isn't that a difference of squares? And couldn't it be 3 minus x and 3 plus x, and one of them looks a lot like that one, and maybe they simplify? I might have boxed it a little bit too early, but do you guys see how with one multiplication, I end up getting rid of my complex fraction? It's pretty nifty. And I didn't even have to think about dividing by the reciprocal. Multiplying by the reciprocal. You could have also done this guy over 1, taken out the division bar, multiplied by the reciprocal, and figured out how that works. I like my trick a lot better. I should probably rewrite this. I kind of just left him blank. That's dangerous. Did anybody notice, though, that when I said difference of squares, like 3 minus x and 3 plus x, that the signs are wrong? 3 minus x isn't x minus 3. But here's a nifty trick. If we ever don't like the order of the signs, we can just pull out a negative and make it what we want it to be. Oh. And then with one quick factoring of a difference of squares, then we get, I'm pretty sure, to that simplified form that the answer key would want us to have. Dun, 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 dun. If you guys are ready, section 1.5, let's get back to our notes. If you want to talk in your groups really quickly about any questions that they have on that problem, you may. Video and notes will be. The next thing is homework time. Alright, any good clarification? And that's with a very solid wooden leg, but very solid chair. And fractionation. I was really worried because it was right above where I had this big old metal plate with screws from a broken foot 2 years ago. You guys might have seen me wheeling around campus for a while. But the nice thing is the plate is totally intact, and if you love x-rays, I have some good ways to show you. Okay. Here we go. But I just have to measure a little bit. We have to get a move for the my dog just doesn't make it well. Alright. We are okay. 2 parts. Alright, we're in section 1.5. And we already talked about the original, or the initial, I should say, illustration in the sense of x is the horizontal distance, y is the vertical distance, something so basic and yet so many details. When it came time to apply it. So, it's a good sketch to put. Not that you needed to like memorize whoever this dude is. It's more of a, okay, just remember, graphically speaking, because we're talking about graphs, horizontal distance from the origin, vertical distance from the x-axis. Okay, but let's get to intervals. So last year, I think you talked about intervals a little bit. And this year, when we were talking about the domain range thing, hey, Stephen, sure. It's okay, I'm moving it. All right. Do you remember how we talked about how far left to how far right? And I said something about negative infinity to infinity. And then how low to how high. And I mentioned something about negative infinity to infinity. I wasn't talking about inequalities. I was talking about intervals. Because intervals show me how left, how right, how low, how high, a lower to a higher quantity. But the weird thing is that intervals can look a lot like ordered pairs. Now, none of these are going to look a lot like ordered pairs because I need a parenthesis for this one to show the left boundary of -2. But I'm going to be able to use a bracket for this one because the 5 is allowed to or needs to be included. Or equal to uses a bracket as an edge, and the other side uses a parenthesis. Now I'm just going to show these other two intervals because that way you guys can start homework tonight, but remember not to until Wednesday. 3 is how low, infinity is how high, negative infinity is how low, and 1 is how high. Ah! Ordered pair! Okay, it has an infinity. You're safe that time. Other times it'll look a lot like an ordered pair. Beware the contact. Hi guys. Good job not packing up too early.